welcome to all. This is Tanu Gupta from Akgec Engineering College. Today I'm going to discuss a very important topic in machine learning technique, that is convolution neural network. We already discussed the concept of artificial neural network, which is based on biological neuron system. Now we start with the convolution neural network. First we understand what is convolution neural network and where it is used. Then we will discuss what are the architecture of CNN, what are the layers of used in CNN architecture, and what are the various types of operation that we are used in convolution neural network to extract the features. So yes, in deep learning uses large neural network with multiple layers to learn the representation level and inherit tools of sample data. In the artificial neural network, we have only 3 layers, that is our input layer, hidden layer and output layer. But in the convolution neural network, it is a large neural network with a multiple layer. Layer is not fixed of any point, input, hidden and output layer. There are multiple layers in the convolution neural network. It is a type of deep learning model basically designed for the object identification, image recognition, classification and computer vision task. Unlike the regular neural network, CNN can automatically special pattern like edges, textures, images without any manual feature extraction. CNN can learn complex patterns, objects because of their multiple hidden layer. CNN basically used to detect the hidden patterns in the image or in any other object with the use of its multiple layer, which is used for the feature extraction, consisting of input layer, output layer and multiple of hidden layers and millions of parameters, and with the use of other features. So this is a architecture of convolution neural network. In the artificial neural network, we have only 3 layers, input layer, hidden layer and output layer. Now this is a architecture of convolution neural network. First is a input layer, second convolution layer, after that pooling layer, then it is a fully connected network, and then the output layer. In the input layer, for example, we have an image. Image is considered in the form of pixels. Now we apply the feature extraction process, which include the convolution and pooling on the image pixel, and then after we will get the image, then we pass the image to the fully connected network, and after applying the activation function, and then we will pass to the output layer for the classification. So basically convolution input, convolution and the pooling part is used for the feature extraction purpose, and fully connected and output layer is used for the classification purpose from that image, because it is we already discussed that the convolutional neural network is designed mainly used for the object identification. If we want to identify an object in a particular image, so we used a convolutional neural network approach that uses a millions of parameters and other feature to extract an object from an image, or in the image recognition to identify the image, which image it is. For example, if we consider there are so many animals, then we have to classify that these are the images of dog, these are the images of cats, these are the images of tigers and so on, for the classification purpose. So initially the 3 layers, input layer, convolution layer and pooling layer, it is basically used for the feature extraction purpose, and the fully connected and the output layer is used to classify the object from an image. So there are 5 layers in the convolution neural network. We can say input, convolution, pooling, fully connected network and output layer. The convolution layer and a pooling layer can be multiple. There can be multiple feature extraction layer in the CNN network, convolution pooling. And like in this, first we have a input layer, then convolution plus pooling, then after that we apply a convolution. If we have a large size of image, then we apply a multiple feature extraction process on an input image to reduce the dimension of an image. Then we process the reduced dimension image to the fully connected layer for the classification purpose. Then we apply our activation functions to get the output. So convolution pooling, convolution pooling, convolution pooling, this is a feature extraction process. Then after that we pass the result to the fully connected layer, which is used for the classification purpose. Then we apply a softmax, sigmoid and ReLU activation function according to the data which we have to classify, and after that pass the result to the output layer to get the output. So this is a architecture of convolution neural network which we have to draw if we ask for the architecture of convolution neural network. These are the operations in the convolution layer. These are the operations in the convolution layer which we have to perform for the feature extraction process. First one is a filter, or we can say a kernel, or we can say a mask. Second one is a stride. Third one padding, and fourth one is pooling. These are some operation: filter, stride, padding and pooling operation that we apply on an input image so that we get the reduced dimension of an image, and also this is a procedure to extract a feature from that an image. Now we will discuss the functions of every layer of CNN. The CNN is made up of 3 different layers: convolution layer, pooling layer and fully connected layer. These are the 3 main layers. CNN architecture is developed with these layers which are layered, which are also layered. The activation function and the dropout layer are more factor in addition of these layers. Convolution layer. So first one is a input layer and then the convolution layer. Input layer, in just we include all the image that we have to process for the classification purpose in the convolution layer. First one is a convolution layer. These layers apply the convolution operation which we discussed in the previous slide, like filter, mask, pooling and padding. These layers, the convolution layer, apply the convolution operations to extract the features from the input images like edges, texture and shape. If we have to extract the features like edges, texture and shape of that image, then we have to apply the convolution operation on particular image. Filter, kernel, slide across the input image to compute the feature map. The filter or the kernel method slide across the input image. If we have an image that, and this is a filter mask, then this mask is slide across the input image like this to compute the feature map. How it is possible, we will discuss within the numerical. First we understand what is the architectures of layers. Now after that, convolution helps preserve the spatial relationship between these pixels. Convolution helps preserve the spatial relationship between these pixels. Also, if we have to reduce the dimension of images, but we have to preserve the relationship between the pixel, or we do not neglect the important feature of that particular image. Now, second one is a pooling layer. These layer down the sample feature map, reducing dimensionality and computational load while retaining the important information. Now in the pooling layer, first one is a convolution layer in which we extract the feature from that input image. Now in the pooling layer, we have to reduce the dimension of that particular image so that we reduce the computational load while retaining the important information from that image. There are common types of pooling performed. We have to perform the common types of pooling like max pooling, average pooling, global pooling, minimum pooling and so on. So we take the value according to our data. Max pooling, take the maximum value. In the max pooling, we have to take a maximum value from that particular image, or mask. In the average pooling, we have to take a average value from that particular image. So pooling layer is a second layer in the CNN network, for which we now next one is fully connected layer. After that, we extract the feature. We have to pass that input to the fully connected layer. These layer connected neuron from all the location to the previous layer, producing the final output such as the classification probability. So fully connected layer are used to producing the final output such as classification probability, so that the particular image belong to which category. To classify that image, they map the learned feature to the target output. Now activation function. Non-linear function like rectified linear unit are applied after the convolution to introduce the non-linearity between these complex pattern. Now last one is a dropout layer, a regularization technique used to present the overfitting and underfitting condition, deactivating the neurons during the training. And overfitting, if we have a data set that does not currently work well with the training data set, then how it will be performed with the testing data set. So if we have a data that lies over the image, so we are going to use a regularization technique to fit the data according to our requirement. So these are the explanation of the layers of CNN network. First one is a convolution layer, in which we have to apply the convolution operation, filter, and so on. Pooling layer, in which we apply two types of pooling, max pooling and average pooling. Then we pass a result to the fully connected layer. After that, we apply a activation function to get the output, and after that we use a regularization technique to produce a actual output. Now, yes, how the CNN work? Like already we discussed, first CNN take the structured data like an image input, typically represented as a matrix. Okay. Now after that, we apply a feature extraction process, convolution and pooling layer. Convolution operation like filter, stride and padding, we apply the feature extraction process and the pooling layer to extract the hierarchical feature. Now the classification and output, fully connected layer, from these to produce the prediction like classifying an image into categories. So basically how the CNN work: input, second one is feature extraction process, and third one is a output or classification. So according to this map, input, feature extraction and classification and output, this is a procedure of CNN to work. Now, yes, 1D convolution layer, one dimension convolution layer and two dimension convolution layer. What is one dimension convolution layer? For example, input one dimension data such as time series data, which is in one dimension, single dimension, or a sequence of number represented as a vector or a matrix with a special dimension. Now the second one is a filter method, one dimension of array weight. Now we have to apply the operation the filter slide along with the sequence, performing element wise multiplication and summing up the result with the each position that produce a feature map. So these are the three parameters which we are going to use in a one dimension convolution layer: kernel size, length of the filter, for example 3 and 5. Now we apply the stride parameter, how far the filter move to each step. Stride, move the kernel marks to the images, like on one position, two position, to across the image. Now after that we applied a pattern, determine if the input image are preserved. Application of one dimension convolution layer are sentiment analysis on a text sequences. One dimension means there are the sequence of numbers in a one dimension row, and after that anomaly detection in time series data. In 2D convolution layer, we got an 2D like images represented in the form of matrix, heights and weight, or 3D color images Filter, a 2D array of weights, multiple filter we are going to use in that images. Now after that, dimension of the filter is obviously 3 cross 3 we are going to use, and 5 cross 5 because there is a 2-dimension input layer. Now the applications of CNN is in image classification, object identification, and image segmentation. So this is a, for example, this is an applications of image classification, object identification, and image segmentation are the application of convolutional neural network. Just take a simple example to understand the various types of convolution layer operation. For example, if we have an input image like 1, first we understand what is a filter or a kernel method. For example, if we have an input image like 1 2 0 1 5 0 1 0 2 1 1 0 1 0 1 1 0 1 0 1 1 1 2 1 0. We have an input image of size 5 cross 5 and we have a mask of 0 1 0 1 of size 2 by 2. Now how we apply the filter mask to the input image? First, the kernel mask is slide across the input image. So understand 0 1 0 1. So 1 multiply 0 plus 2 multiply 1 plus 2 multiply 0 plus 1 multiply 1. So we replace the value of this 1 multiply 0 2 plus 1, that is 3 in this image. Now we move the filter mask according to the stride, that is 1 or 2 according to your given question. Then we move the slide according to this and this, after that this, and then. So this is a basic procedure of how the filter mask move with the stride value to the input image. So these are the operation that we applied on the input image to get the features from the input layer. That's all for this.